Hey guys, Professor Goodman here. I'm going to take a look at the homework that's due for next week. So this is all dealing with Chapter 9. We're looking at, last couple of weeks, we were looking at probability. This is a small extension of that, just not quite, not as formula heavy. There's a few, especially in the second part of Chapter 9, most of it is uh, even though it's kind of small, like it's through distribution we can use Excel for, and even this stuff is not that bad. It's just knowing how to find what it is you're looking for. So I'm going to go through like maybe a problem or two on this homework, and then a problem or two on the next homework as well, and you guys can see how this isn't way too horrible. All right, the first one, this guy isn't too bad. You should be able to understand how to solve this guy once um, once I go through problem 2. So problem 1 you can answer after I finish problem 2. Problem 2 is kind of lengthy, so let's do this one together. Alright, so first things first, they give us a probability distribution. So remember we talked a little bit about probability distribution. It's simply you're given your variables, which some random variable where you have x, and then corresponding to each value of x, you have its corresponding probability. So whatever x equals 0 means, we know that has a 20% chance to happen. So the event x at 0, 0 will mean something in the problem. In this case, the problem reads, the number of cars sold at Jim's Auto Sales each hour is the random variable x with the following probability distribution. So in other words, each value x is a car sold. So if you got x equals 0, then this means that in that hour at Jim's Auto Sales, he sold 0 cars. And now each hour he has a 20% chance to sell exactly 0 cars, right? So that's how we would read this probability distribution. So what they ask is, what is the probability of at least 2 car sales in a randomly chosen hour? So first thing that I would do, of course, is copy this over and put it into Excel, because Excel is gonna help us out quite a bit here. So we'll paste this guy. Again, it's going to have some images, or yeah, it's going to have some images which it doesn't like. You can leave those there, or you can, in my case, I'm going to take them out. This is our x, each value x, and then this is the probability that x occurs. Alright, so, so the question asks, what is the probability of at least 2 car sales in a randomly chosen hour? So in other words, if we were asked to put it in this form, in our probability form, this is what we would do. Probability that x is greater than or equal to 2. Now you don't have to do this. I'm just doing this so you guys see what I'm doing. You can just right away find your answer. But just so you guys can see when you guys are looking at this, watching this video, and go, oh yeah, that's what he's doing. So it's just for you guys. Alright, so we want the probability that x is greater than or equal to 2. So in other words, what's the chance that in like a given hour, this guy sells at least 2 cars? So Jim's Auto Sales sells at least 2 cars. So pretty much what this means is this is the probability that x is equal to 2, right? And then plus the probability x is equal to 3, right? Because he could sell exactly 2 cars. He could sell exactly 3 cars, or he could sell exactly 4 cars, so equal to 4, and then that's it, right? We're only given up to 4 cars per hour. I guess if you sell 5 or 6 cars in an hour, that might be kind of crazy. But this right here is what we're looking for. So in other words, here we have x is 2, right? So we just take this probability and sum it with the probability that x is equal to 3, and sum with the probability that x is equal to 4. So all you have to do is sum, and then click on the probability that corresponds to x is equal to 2, so the first part of this formula, and then just sum all the other guys up too, right? This would be at least 2, because we have 2, 3, and 4. So close that off, and our probability is 0.73. So what I would do is I would copy it, and then I would paste it into this box. And I already did this problem a while ago, so it's already there. So I would just paste it in there, and you can see that 0.73 is correct. That's exactly what we got. Alright, so that's the first part of this problem, so let's keep going on. So now it says, suppose it is known that less than 3 cars were sold in a particular hour. What is the probability that the number of cars sold was more than 1? Okay, this guy's tricky. So we're given a constraint, right? We know that his company didn't sell 3 cars or more. They sold less than 3 cars, which means that it's going to be a conditional probability. So what we have is probability, and then we're going to have some kind of something we're looking for. So the probability that the number of cars sold was more than 1. So in other words, we want more than 1 car to be sold, but we're given a constraint, right? We know that in that hour there were less than 3 cars were sold. So in other words, what's the probability that x is greater than 1, i.e. more than 1 car was sold, given that we know 3 cars, that we did not sell 3 cars, we sold less than 3 cars. Alright, so remember the conditional probability, we have to find 2 things, right? We have to find the intersection between these two, and then we have to find just the probability x is less than 3, right? We have to find our constraint. Okay, or our condition. So here, this is x is greater than 1 and x is less than 3. Now this looks like it might be kind of tough, but it's actually much, much easier than it looks. And then here is x is less than 3. Because remember, our conditional probability is their intersection divided by your constraint. So it'll be this guy and this guy divided by just this guy. Okay, so let's find this one. So this one is saying, all right, we want to find the intersection between x is greater than 1 and x is less than 3. So x is greater than 1, so it's not including 1, so we start at 2, right? So the first part is 2, 3, 4. All right, but now look at the second part. It has to be also less than 3, not including 3. So that means it has to go all the way down this way. Well, the only guy that is in this intersection of greater than 1 and less than 3 is 2 by itself. So that's the answer. So just 2. Right? Does that make sense? X is greater than 1. Since there's no value between 1 and 2, you have to go right up to 2. X is less than 3. Since there's no value between 3 and 2, you have to go down to 2. So 2 is the only one in their intersection. That's how we got that guy. Alright, now this guy is just, well, everything less than 3. So not including 3, right? This inequality here says that it's strictly less than 3, which means it cannot be 3. It gets infinitely close to 3, but never attains it. So we have to go to the next value. So 2, and everything less than 3 would be 2, 1, and 0. So we can just sum this. Okay, so now we have our 2 probabilities. So this is your numerator, remember? And then this is your denominator for conditional probability. So denominator. All right, so do equals, click on your numerator, divide, and then your denominator. And there we go. So I'd copy this guy over, and then be very careful when you paste it, make sure that you read this part. If it says rounded to the nearest thousandth, don't just leave the whole answer in there. Paste it in there and then round as necessary. So delete all the way up until you get to your third decimal, or 4 decimals, and then round to this third one. Okay, so which is what we got, right? 0.518, we got 0.517, but if we round it to the thousandth, it would be 0.518. All right. Okay, so 20 minutes after Jim opened his store, he sold 2 cars. What is the probability that these are the only 2 cars he will sell in that hour? This guy right here is kind of tricky. So the 20 minutes seems like it might be important, but all we know is 20 minutes is less than an hour. So this right here, we're given, okay, in less than an hour, he sold 2 cars. What is the probability that these are the only 2 cars he will sell in that hour? In other words, this is saying, okay, he already sold the 2 cars. What's the probability he will sell 0 cars now? So that means only those 2 cars for the entire hour he sold. So again, this is a conditional probability because we're given he sold 2 cars already. What's the probability that he only sold those 2? So in other words, this is what it's going to look like. So our probability that x is equal to 2, remember, because what's the probability he only sold, he didn't sell any more cars, meaning he only sold those 2 cars that he started with in the first 20 minutes. Given that x is greater than or equal to 2. And now it's greater than or equal to because, remember, right at the beginning of the 20 minutes, we know he sold the 2 cars. He could possibly sell more cars. So it has to be greater than or equal to. So we're saying, what's the probability that he sells 2 cars exactly, given that he's already sold at least 2 cars in that hour? Okay, so again, it's another conditional probability. So we have to do x is equal to 2 and x is greater than or equal to 2. Okay, and then this part. So probability, now x is greater than or equal to 2. Okay, so let's find these. So the intersection then between x is equal to 2 and x is greater than or equal to 2, well, there's only one number that has both x equal to 2 and x is greater than or equal to 2, right? Just x is equal to 2. So that one was pretty simple. Now this part, x is greater than or equal to 2. So that means we start at 2 and we go all the way up. So we sum these probabilities. So let's do sum. Sum starting at 2 and going all the way up through 4. Okay. And now our this guy, remember, just like before, this guy goes in our numerator, this guy goes in our denominator. So click on this guy for numerator, divide, this guy for denominator, and there we go, about 39-ish%. So you copy this guy over, so you just copy, and then you would paste, and round to the nearest thousandth. So you see we got the same answer. Okay, so that's all of these probability parts, and now it asks what is the mean number, so the expected value of hourly auto sales. So in other words, every single hour, how many cars can we expect to sell approximately on average each hour? So this one's actually pretty simple to find. The formula for finding your mean of a probability distribution is simply you take your x, so the mean of I can put it down here actually. So mean of P of x, so probability distribution is, now this is just showing you what it's like, this isn't what you're actually going to do, but it's basically x, so your x1, or whatever your value is, your x1 times probability of x1. Then you add x2, so your second x value times the probability of x2. And you just keep going until you've gotten everything. So in this case, we'd go all the way up to x4 times probability of x4, right? So that's what we would do. But there's a really fast way to do this. Remember, this is a product, and then this is a sum, so we're summing up all the products. Well, there's a built-in function for that, sum product. So select, we know how to use sum product. It's just like finding the mean of a frequency distribution. So you select all of your x, comma, all of your corresponding probabilities of x. Enter and you get 2.33. That is the mean. So sum product does this by itself. You don't have to worry about doing anything with it. And then there you go, 2.33. So that's it. So that's how you find your mean. All of this stuff pretty much the same. So find the expected value for a random variable x whose probability function graph is displayed. So you'd use this graph to find your expected value. You might have to make a table out of this. So like your x is 0, there's 0 of them, 0%. Then here looks like it's 0.05%, and so on. So you just know how to read these tables, and then do the last thing that we just did. And then here we go. find the expected value again. So this would be same thing, and same thing, and almost the same thing, but you should have to fill this guy in. Not too bad. Just remember that in a probability distribution, all of these numbers, so whatever this guy is, they all have to add up to 100%, or in this case, since they're all decimals, has to add up to 1. So I would do 1, so like in Excel, do 1 minus the sum of all these numbers, and then whatever's left should be this guy. Then find the expected value as normal. Okay, now this one is slightly different. It doesn't just want you to find the expected value. It doesn't want you to just find their mean. It wants you to find also the variance and standard deviation. So this can be kind of different. And I looked at the solution for this, and it's a little complicated the way they're trying to explain it. So I'll just show you the fast way to do it. So this is the only way you really need to know how to do it on your for like your test and your homework. Okay, so first things first, it's another probability distribution, so let's copy this guy over. Okay. And he's a little longer than the other one, so just know that there's more numbers there other than what I'm showing. Let me get rid of these. So this is x, and this is probability of x. So just my distribution. Alright, so first things first, we need to find our expected value of x. We need to find the mean of x, of our probability distribution. So we know how to do this, right? So mean of probability of x, well, that's simply sum product. So this is pretty nice. So I kind of like the frequency distribution. You don't have to worry about that annoying division there at the end. Oh, this guy's freaking out a little bit. But you don't have to worry about that summing up all of the numbers and doing that. All you have to worry about for this is just doing the sum product. And then we got it. So sum product, my first array, I don't know why it was doing that weird thing. Comma, it's like double comma-ing. I'm not sure why it's doing that. So I'll might just be for some reason not wanting to do this the right way. Maybe these cells have some kind of weird problem. Let's try down here, I guess. Sum product. Okay. So it's B1. I think it goes all the way to P1. Yeah, I'll just type it in. So B1 to P1, comma, and then B2, see the red, B2 to P2. Alright, so now I've got all of this done. So remember, this guy is your mean, right? So mean of P of X. Okay, so you'd say, I think it says round to the nearest hundredth or whatever, so you just round this guy to hundredth, so 8.10. And then it gets tricky. It asks you for the variance of the random variable x. So there's a long drawn-out formula where you basically take each one of these, you take this guy and you square him, and you subtract this guy from x squared times its probability. So remember before how we found this guy by hand? It was take this x value, multiply it by your p of x, sum it to the next one. 2 times this plus 2 times its respective probability, 4 times respective probability, and so on. So you do all of that. You have to do all of that, but this time instead you square the x's. So let me show that down here. And now don't worry, there's an easy way to do this one too, but I want to just let you guys know that this is how you would find it. So what you would do is you would take every single one of your x values, you would square them, and you would multiply by the probability that that x happens. So you do this for every single x value, so x1, x2, x3, x4, x5. And then you would subtract off the mean that we found before, so this guy, the mean of p of x squared. So this is how you would find the variance of p of x. Now, here's an easy way to do it. Okay, so again, we're going to use sum product. So start with sum product. And now we need x to be squared. So you can do it either of these ways. This way, and then you could put parentheses around it and square it. But that way can be kind of easy to forget. So there's another trick. Just highlight it twice. So see, I highlighted it with the blue, and now I'm highlighting it also with the red. Okay, but for some reason it's freaking out on me. I don't know why this is happening. I think my Excel's acting strange. So let me try this again. So sum product equals sum product. Okay, so all of this. So this again. Okay, so B1 to P1, comma, and again B1 to P1. So do that again. So see, I highlighted my x twice, so it's going to square the x's now together and sum them, and then highlight your p of x. Okay, so that's the only difference. When you're finding your variance, you have to do the sum product of your x values twice, or you can just square the x, either way. Alright, so that's the first part of the formula. That gets us this part here. Now we need to subtract the mean squared. So minus, now click on your mean, we found this before, and caret for the square, and 2. So see, sum product, do your x's twice, that gives you x squared, and then the probabilities, right? So the probability of x, just do that one once, and then subtract off your mean squared. And there we go. Our variance is 26.12 something. And that's what we got here. Okay, so now it would be helpful to remember the relationship between the standard deviation and variance. So if we have the variance already, finding standard deviation is very simple. So standard deviation of p of x, well, it's simply square root of the var of p of x. Right, so once we find once you find the variance of your p of x, finding the standard deviation is very simple. Just do equals and do square root, so SQRT. Click on your variance, and there you go. That is your standard deviation, 5.11. So you put that in, and it would be correct. So that's all of chapter 9. So see, there are maybe a few tricky things, but for the most part, it's just making Excel find what you want. So it's not as much stuff you have to do, mostly by hand, like last week's and the week before. Maybe still a little bit of it, but not quite as much. And this is the same thing with the second part. The second homework actually is very, very simple. Shouldn't take very long at all to do it. So that was chapter 9.1. Now we're doing chapter 9.2, and this is binomial random variables. So in class we'll go over what a binomial distribution is and what binomial random variables are. There's certain cases you have to have in order to have a binomial random variable, but I think in all of these problems you just assume that it's already following a binomial distribution, so you don't have to worry about that. In Lagunitas, in the reading, you'll probably read about that. Well, let's start it. Alright, so they say here x is a binomial random variable with n is equal to 9 and p is equal to 0.2. Now remember, n equals 9, this is your number of trials, so this means you're going to do 9 trials, and then here p is equal to 0.2. This just means, okay, among all those 9 trials, each one of these trials you have a probability of 0.2 to succeed in whatever study you're doing. So like if it were like flipping a coin and I wanted heads, in 9 of my trials, let's say my probability of getting a heads was 0.2. So in other words, if I get the head, it's a success. And P deals with the probability of that success. So first it asks, this is probably the only really annoying part, is in how many of the possible outcomes are there exactly 5 successes? So now, for this stuff, it can be a little tricky. Like you'll have to know a formula for this one. But essentially, what this is saying for a binomial distribution is you're basically saying, okay, in how many different ways can I have 5 successes out of 9 trials? So in other words, 9 trials choose 5 successes in case you're good with combinations. So it's the same thing as 9 trials choose 5 successes. So in other words, how many ways can I have 5 successes in these 9 trials? Now, if you don't know the formula, it's not horrible, but this is it. It's in. Now remember this exclamation mark. This means factorial. What does factorial mean? Well, if you have 5 factorial, it's the same thing as 5 times 4 times 3 times 2 times 1. So in other words, it's the number itself, then times the number 1 less than it, 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 all the way until you get down to 1. So this is what 5 factorial would look like. So n factorial would be n times n minus 1 times n minus 2 times dot 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 times 2 times 1. So however large your n is, this would be it in general. Okay, so n factorial. So this is this is how we would find how many successes. So n factorial divided by open parentheses because the denominator is a little larger. K factorial. I'll tell you what k is here in a second. Times n minus k factorial. So it's k factorial times n minus k factorial. Alright, so this is our formula. Looks better if I could write it out, you know, but I can't really in Excel. Yeah. So anyway, so n of course is trials. K is number of successes. So here we had an n, we had our n, we had k, and we have p. So we'll need these. N was 9, okay, and k, well, k was what we wanted, which was 5 successes. So our k is 5, and then our probability of getting those successes was 0.2. So this guy right here. Alright, so we don't need p for the formula, we just need our n and our k. So let's go ahead and start writing this out. So I'm just going to do it all in one foul swoop. So in order to get how many ways can we get exactly 5 successes? So this is the kind of question you would answer with this formula. So take your n factorial. So in Excel it's fact. Okay, so fact, now click on our n, right? So fact n, so n factorial, and then divide. Now you're going to need to open a parenthesis here just in case, because it is multiplication, but there's a chance that this subtraction could screw things up. So it's also good just to get in the habit of putting this stuff in correctly. So fact here, okay, and then we have another fact, right, because it's k factorial. So fact of k, close this guy. Then times fact again, because we want the factorial of n minus k, so their difference. So now click on n minus your k. Okay, so I know it looks kind of crazy, but this is what we're gonna have to start getting used to. We gotta start getting these slightly larger formulas into Excel. And here we go. Okay, so I did n factorial, and this is divides. So divided by k factorial times n minus k factorial, and I get 126. So in these 9 trials, we have 126 ways to get exactly 5 successes. So like if you're thinking about it, remember, if we were making our sample space with 9 trials, and we wanted exactly 5 successes, so like a sample, one of the things in the sample space would look like, you know, success, 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 failure, success, success, failure, and so on, all the way until you get 9 of them, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you'd have to list out every single one of those, your entire possible sample space, and then count how many ways you get 5 successes. And you can see 126, that's an awful lot of counting, so this formula helps us out quite a bit. Okay, so that's how we can find exactly 5 successes, by using that formula. So throw that in there, and we got it. Now it asks us for the probability of 5 successes. So this guy is actually a lot easier. So to find the probability that x is exactly equal to 5, this is what we need to do. Since this is a binomial distribution, so we know it's binomial based on the criteria for binomial. You have to have a fixed number of trials, a fixed probability of success, and there's a few other things. But since we're doing this in binomial, I think does it even tell us it's binomial? Yeah, it says it's a binomial random variable, so we don't have to worry about checking it. All right. So this is all you have to do. Binom.dist. So like I said, in Excel, it's very simple to find what you want. Just start typing what you want. Start typing in binom, pops up. So you have number of successes, then as an input, number of successes, number of trials, probability of success, and then whether or not it's cumulative. That last part can be kind of difficult, but I'll try to explain it as best I can. First off, we need number of successes. So we still want exactly 5 successes. So click on that. So there are 5 successes. Our number of trials, well, there's still 9. And then our probability of success is 0.2. Okay, now cumulative. This is cumulative just means, okay, are we only working with an exact number, or do we want multiple successes? So like cumulative, you would put 0 if you want exactly 5 successes. So if you want it exact, you put 0 for cumulative. If you want up to that number, so like less than or up to number, then you would do 1 for cumulative. So think of it like in a computer language, 0 means no or off or fail, and 1 means true or I guess 0, I mean false, sorry. So 0 means false, 1 means true. So it means yes, I want cumulative. Now, these guys can be very tricky, so you'll have to start kind of getting used to them. But for this case, we wanted exactly 5 successes, so that means we put 0 for that. You copy this guy over, and you would paste him, and you see we get the right answer. So to the 6th decimal place. Okay. So here we go. Here's another problem. Problem 2, probability of having this. I'll let you guys do this part. This is pretty simple, just finding your n and your p. But then this part is where it can get kind of difficult. So this is, what is the probability that at most 5 of these women produce identical twins? Now, if you're not so good with your English in mathematics, this can be kind of difficult. Remember, up to or no more than, those are all the same thing, right? So at most, no more than, so like no more than means at the absolute most, is the same thing as at most. And it's the same thing as up to. So I mean, it goes on, right? And then you have the other side. That's saying, this one says you have like a top value, right? This one down here, well, this is at least. Same thing as, there's quite a few of these. For some reason I can't think of any right now. But at least more than or equal to. Because more than would be without it. And so on. There's quite a few of these. But this is saying you have a beginning value. So a bottom value. So you start somewhere different. No more than means you have to end at that value, but at least means you have to start at the bottom and work your way up. So in a binomial distribution, so in this case we want is at least 5 or up to 5. That's this first case. We have a top value. And that's good because when you have it the other way around, it's very difficult. So x is less than or equal to 5. Okay, so do your binom dist. Okay, and now do the exact same thing. But in this case, I think in the first part, your n and your your n and your p change. So your n is 3,000. So I'll put that there really fast. Actually, it's probably be a good idea to do that first, just so we know we're working in a different example. So we need our n, then we need our p, and oh yeah, we need our k as well. So k and p. Okay. There we go. All right, so n was 3,000 from the problem. K, we read that in the problem. I think they said they wanted at least 5, so 5 is our magic number. And then our probability was 1 divided by 285, I think. So yeah, just read this problem and you'll understand. Okay, so we want the probability that we have x is less than or equal to 5. Okay. All right. So here we go. So again, it's binom dist. Okay, number of successes. This is the same thing. Just click on your k. Then your trials, click on your n. Okay, and then your probability of success, click on your p. And now it's cumulative. So cumulative means, is there more than one case? Well, yes, there is, because x is less than or equal to 5 is x is equal to 0, x is equal to 1, x is equal to 2, all the way up to 5, right? So you'd say yes. So when you do cumulative, this is what happens. It'll do probability x is less than or equal to, I don't know, we'll just say k, because k is our number of successes. So this is what it's going to look like. It'll do, okay, probability that x is equal to 0 plus probability x is equal to 1 plus, and then all the way up to probability that x is equal to k. Now be careful. If you're trying to do cumulative, so this is the part that gets a lot of people. This is tough. If you're doing cumulative with this, so probability that x is at least something, you cannot just use the binom dist, because this is different. Binom dist, the value you put in for your k, that's the top value. So you have to use complements. So you'd have to do 1 minus everything less than k. Probability x is less than k. So if you wanted to do this guy and use the cumulative, you would have to use this. Now I don't think there's any problems like that here, but know that that might come up. But here we finished. So I'd copy this guy over, place it here. This would be probability of having at most, or 5 twins, I guess. Okay, so then this last part's easy. What Excel function did you use? Put it exactly in, so all caps binom.dist. And then that's it. So that's all of chapter 9's homework. Not way too terrible, but if you have any questions, you're more than welcome to